These are BC Calculus Notes 4-2. A solution to a differential equation is a function or a relation. If a differential equation has one solution, then it has infinitely many solutions. If we have y equals f of x, the input we know is x, and the output is going to be y, or we use the f of x function notation to show the same thing. Now, let's suppose we have y prime equals f of x and y. We use that notation to represent a differential function. For example, you can see we have 4 of them listed here. Each one of these are functions that are differential equations. In these, you'll see that some of them have x's and y's, one only a y and one only x's. Algebraically, the inputs then on these differential equations could be x, could be y, or both of them. Both of them in these two, only y and only x. The output value will be the value of that function, or in this case, whatever that derivative is, at whatever point we have, so whatever x, y value that we use. Graphically, in a differential equation, if the inputs are x and y, then the output is going to be the slope at, or slope of the curve at that particular point. Slope of the curve, derivative. Slope of the tangent line. All those mean the same thing. A graph of the infinite solutions to a differential equation will be something called a slope field. We're going to take a look at those today and concentrate on slope fields. To construct a slope field, we're going to do the following things. We're going to draw little short segments or tick marks in each one of the grids. Each segment will represent the slope or slope of the curve at that point, or each tick mark will represent that. Always start with these at some easy points. For example, whenever we have a slope of 0, 1, or infinity, those are pretty easy to draw. Then look for patterns to help fill in the rest of the graph. We have a couple examples of slope fields down below. You'll see in this one we have a slope field, and in that you kind of see a ghost of the family of solutions. It's not really an actual curve that you can see, but you can see a resemblance of that. If we're given a specific initial value, for example in this one we're given the initial value of 0, -1, we can start there and then go with the flow from there. You'll see that the slope is pushing us this way, and then the slope changes and takes us back up in this direction. Same thing from the other way. We have a slope that changes, which then is going to change our curve as we go with the flow. Let's practice a couple of these. Our first differential equation gives us y prime equals 2 times x. We've got a quick little table that we use to help us build these if we need to. In it we can record x values, y values, and then the value of that derivative. In this case, it doesn't matter what we choose for y because y prime is not a function of y. All it is a function of is x. So when x equals 0, y prime will equal 0, 2 times 0. So all of these values here, where x equals 0, we can put our little tick marks in here. Each one of these you can see are horizontal. They're little tick marks representing at that point that slope of this curve. Let's look when x equals 1. When x equals 1, the slope of our curve, 1 times 2, will give us 2. So we're going to go in here and put a tick mark at x equals 1 that represents 2. I may not fill in all of these, but I am going to fill in enough to kind of show you what that pattern is. Okay? I'm not measuring precisely, but you can see I'm going to try and make it as close to 2 as possible. If my slope, or excuse my x value was 2, then the value of y prime becomes 4. So at every spot where x equals 2, I'm going to have a steeper slope to each one of my tick marks, trying to match or guess as best possible what 4 would look like. All of these better be relatively the same slope. Let's take and fill in maybe the other side here. So we know that when x equals -1, y is going to equal -2. So we'll go to -1, and all these values of -1, we're going to give a slope of -2. And then, if we use -2 for our x value, -2 will give us a, oops, forgot to write that down for us. That will give us a slope of -4. And hopefully you see that this kind of looks like the previous examples. It's not a specific curve, but a ghost or a family of ghosts showing us where a particular graph might be. Let's build the next one. In our next one, we're going to use x, y values, and this time it's going to matter what our x's and y's are because our slope is dependent on both x and y. And let's start with something easy. Remember, always choose some easy points to start out with. Probably our easiest thing is just get rid of this denominator. Let's just say y equals 1. Whenever y equals 1, we can easily adjust and figure out what y prime is. And let's just randomly just say, all right, whatever x we have. Because now all of a sudden, whenever we put in an x value when y equals 1, the opposite of x will be the slope at that. So, in other words, when x equals 1, the slope is going to be a -1. So, I'll go over here to y equals 1, x equals 1, and put a little tick mark of -1. Let's say x equals +2. We'll go to +2, and where y equals 1, we'll put a tick mark that represents -2. And so on. This one, of course, would be -3. We go the other direction here, you'll see that on this side over here, when we have a -1 for x, opposite of -1, I'll have a +1 slope. When x is -2, our slope will be a +2. When x is -3, our slope will be a +3. While we're at it, let's address this value in here. If y is still 1, and x is 0, we're going to get a 0 slope, which means my tick mark here at y equals 1 is 0. And for that matter, what if we used all of these positive values for y? It doesn't matter what those are. When x equals 0, all of these are going to be horizontal lines, 0 slopes. And the same thing for the negative for each one of these. And down here, doesn't matter what y is, all of those are going to be 0. Of course, it doesn't address the issue we'd have when y equals 0. We can't have that in there, so we're not going to put anything for that value. But let's take a look at what if y is -1. We'll do the same thing. We'll just choose values of x, because this one's nice. When y is -1, our slope, or y prime value, is going to give us x. I forgot to put the 0 up here. We know that all those slopes were 0. So we'll go back to 1. This time the slope when x is 1, the slope is going to be 1. When x is 2, the slope is +2. When x is 3, the slope is +3. And of course I'm still on this line, y equals -1. I go to the other side, x is -1, -1, -2, -2, -3, -3. Okay? So Again, I'm just putting these tick marks in as we go. While we're at it, let's go ahead and address what's going to happen at all of these. That's, of course, our x-axis, and the x-axis will occur when y equals 0. It doesn't matter what x is, we're going to get an undefined slope here, right? We're going to get, sorry about that, we'll get whatever x value, the opposite of that, divided by 0 is undefined. And we know that an undefined slope is a vertical line or a vertical tangent. So we can come in here and put a bunch of vertical tick marks. So hopefully you can see where this pattern's coming. We can probably choose, maybe pick and choose a few more points as we try and fill this out. Maybe even choose y equals 2. And for each one of our x values, we're going to get the opposite of x divided by 2 for each one of those. So up here at 2, we'll have a negative 1/2, a negative 1, a negative 3/2, and on the other side, this will be a positive 1/2, a positive 1, and a positive 3/2. If y is negative 2, we'll get a slope of x divided by 2. So at positive 1, we'd have a slope of 1/2. At positive 2 for x, we'd have a slope of 1, 3/2, and so on. You can kind of see how that's going to kind of fill this in. And hopefully what you can see on both of these are, we're going to get a general shape, looks like parabolic in here. Hopefully you see a shape of a circle that we would get in here as we look at those. Next, let's make a specific graph from a given point. This slope field is of the differential equation y prime equals x plus y. If we go to the point 0, 1, this might be a little confusing as you look at it, but obviously you can see the y-axis and x-axis, but each one of these dots represent one unit. So there's one on the x-axis, one on the y-axis, negative 1 on the y-axis, negative 1 on the x-axis. So if we go to 0, 1, we're at this point here. And what it's asking us to do is sketch the solution to this curve. We are not connecting the points, or excuse me, dots. We're not just going from dot to dot to dot. What we're going to do is kind of go with the flow. If we go from here, our slope is taking us up and in this direction. I'm just kind of following the way the slope field goes. The same thing in the other direction. You can kind of see that that would have come from this direction. That would be the curve that we would sketch given the initial point 0, 1. Let's do the negative 2, 0. We're going to go to x equals negative 2, y equals 0. And from that one, you'll see that this slope is bringing us down in this direction. As we go with the flow, you can kind of see this as maybe water flowing through some channel of some sort. But you're just following the slope curves, or the little tick marks that tell us to drop this curve down in that direction. And again, going in the other direction, it's probably going up similar to what we had before. That would be an example of this one going through. I have to go through that point and just, as best I can, just kind of follow the flow of each one of those. Let's try another one. In our second one, we have a slope field for y prime equals 2 minus y. We're going to go to the point 0, 3. This one might be, well, it's definitely harder to read than the last one because they're kind of benign on what they give us. They tell us that that is 6, so I'm just kind of going halfway in between, so looks like right about there would be halfway in between. That should be where 0, 3 is. Looks like this is 2, that is 1, 1, 2, 3, 4, 5, and 6. Hopefully those are pretty close to what we have. So again, we're going to start here at 0, 1, 2, 3, and we're going to follow these little tick marks, which you can see start at a really steep slope here, and then level out, and go to a horizontal slope in that direction. So more than likely, this is going to come down in that direction and then just kind of level out and go to here. That would be the one at 0, 3. Okay. Next question asks us, find the limit as y, the limit of y as x goes to infinity. To help maybe see that, I'll draw in maybe another curve here. We'll see if I pick a point out here. That one is taking me down in this direction. Same thing in that direction. So as x increases, you can see I'm going that way. Let me do one from below. I'll just pick a point here at -4, 0. And you'll see that the slope curves are pushing us up in this direction. And then the slopes just kind of settle down and go like this. And what you should see is as we pick all of these points, okay, let me choose another one maybe right here. This one, slope, these little tick marks are pushing us up in that direction. All of these are going to this horizontal line here. So the limit as x goes to infinity of y, you can see everything is pushed down to y equals, sure looks like about 2, so we'll just say this limit equals 2. Let's take a look on our next page. In the next page, we're given 4 slope fields and 4 equations. What we're asked to do is match those slope fields to each one of these equations. So I'll just start out here with the y prime equals x. You'll notice in this one, y prime is going to stay the same no matter what value we have for y. It's only dependent on x. So, for example, if x equals 1, 1, I put 0. If x equals 0, y prime will equal 0. If x equals 1, y prime will equal 1. If x equals -1, y prime will equal -1. So we want to look at these graphs, and the first thing you want to look for is, are all the slope fields the same for each x value? You'll see in these, they're not all the same. Okay? Over here, you'll see that, okay, they do look the same. Same with this one. If I look at this particular value of x, all of those slopes look the same. This particular value of x, all of them look the same. Whereas this one, on that particular value of x, they're changing. So we know for sure that A is either going to be B or D. So let's look closely at the easy points. If we look at these value, or the first one we did, we said, hey, if x equals 0, if we're on the y-axis, our slope should be 0. It pretty much looks the same for both of these. When x equals 0, our slope is 0. Let's try a 1 and or x equals 1. You'll see that y prime is 1. So we go out here to 1. Not much difference between these two. Same thing at -2, or excuse me, -1. So just guessing those, we can say, hey, don't know enough to tell. But then, as we go out a little bit further, at 1, 2, 3, 4, you can see these are pretty steep here. That sure looks like 4. But when we go over to this one, 1, 2, 3, 4, we definitely aren't steep. And as a matter of fact, we've got negative slopes. So, in this case, A, y prime equals x, is this graph. We'll look at the next one. The next one, now, let's go back to this one. As I scan this, you'll see there's only one other option here that is only dependent on x, and that's y prime equals sine of x, which obviously we know is going to be this one, but let's look at it a little bit more in detail so we know what's happening here. Again, when x changes, it doesn't matter where I go, I still have the same slopes for each one of those. But hopefully you can see the sign is going to give us that wavy effect in each one of these. So equation C, y prime equals sine of x, is this one, which means now we're down to the y prime equals 2 minus y. This one is different from the first one, but similar in that it's only dependent on one variable. When we get a y value, it doesn't matter what we have for x. So what we're going to do is look horizontally and see if all the tick marks all look the same. Definitely not these guys. And this one isn't so. But look at this. When I choose, what's that, say y equals 2, all of these have the same slope. Y equals 1, all have the same slope. Y equals 0, all have the same slope. So just by a process of elimination, we know for sure that B is, or equation B, y prime equals 2 minus y, is this graph here. And then just some other things to take a look for. We can see here when y equaled 2, when y equals 2, you can see 2 minus 2, y prime would equal 0. So if we had others to distinguish between, that would be a good distinguishing thing to check for. That look for the easy ones. Look for your zeros, look for your ones. Obviously, the last one here, D, y prime equals x minus y, is going to be this one. But again, make sure we understand why. You'll see that whenever x and y are the same, or y equals x, we should get y prime equal to 0. And in this case, that's what we're showing here. You'll see that all of these slopes here, well, a few of those are in detail, but on the line y equals x, we should have all 0 slopes for that one. And again, you can just test a few other points as you go through this one to check those out. Okay? Lastly, you should be able to do slope fields on your calculator. You should have the program slope field on your calculator. In order to use this one, what you're going to do is go to Programs, choose your slope field program, and when you press Enter, it's going to ask you for an equation. So in order to put this in, you need to put this in double quotes. The double quotes is the alpha and then the plus key to put that in there. That's the syntax that's required. So if we wanted to do, say, x squared minus y, we're going to have to use the alpha key to get our y in there. So this would be alpha, and then press the 1 for the y, and then make sure you press the alpha key and close the quotes. Next, it's going to ask you how big of a graph you want to do. Typically, -5 to 5 is good enough, unless there's more, or it specifically asks you for more. So what you can see here is all I'm doing is put in my x-min, x-max, y-min, y-max to match whatever was required. And then just wait and let the calculator do the rest. Please take some time and play with that. Make sure you can put that all in correctly, and compare graphs with each other. And that will conclude your notes. Your homework tonight will be on a worksheet. Enjoy, and hopefully all of these notes make sense for you.